All right, and now to the meat of the topic today. I don't know if you guys know about GDTF and MVR. GDTF is the general device type format. It's an open standard for describing devices in the entertainment industry. Used for lighting fixtures, trusses, distribution boxes, media servers, lasers, and all kinds of devices. And then MVR is My Virtual Rig, is a file format which is also an open standard, which allows programs to share data and geometry of a scene for the entertainment industry. I won't say more because we're lucky to have two experts with us today. We have Petr Vaněk from Robe Lighting and Arnaud Grosjean from Moment Factory. Guys, please pick up the sharing with your slides and introduce yourselves.
Very good. So thank you for the introduction. I'm happy to speak here at the Metaverse Standards Forum about the GDTF and MVR, a project from the domain of the entertainment or live entertainment industry. So my name is Petr Vaněk, and I am a customer service manager at Robe Lighting. Today here I'll be presenting or discussing the general device type format and the My Virtual Rig format. I understand that you hear the words, but you have no idea what they mean, so I'll try to describe them. Hopefully you will learn something by the end of the session. And here in this meeting, I'm mainly representing the GDTF group, so I'll use Robe Lighting sort of as the vehicle to explain the angle of the live entertainment we come from, right? So Robe Lighting, we are a leading moving head manufacturer. We are based in the Czech Republic, and we manufacture static moving head fixtures. We also design and manufacture lighting consoles in the UK or electrical distribution boxes in Australia. But what you typically see are the results of our work. So you might enter into a theater or go into a live event venue, and you're typically surrounded by music, by nice atmosphere, haze, lighting. And you might not even realize that all this beautiful scenery is created by some pretty crude elements if you compare them to what they create, right? So these are some of the devices we actually design and manufacture. And while to you, they might all look the same. To me, they all have different functions and features. Some are maybe good for creating nice, well, let me use the word volumetric in real life, beams in the air. Some might be special for maybe spotlighting, some for key lighting of the actors, and so on and so forth. They might come in different shapes and variations, LED-based, maybe looking like LED pixels, panels a bit, and you might not even realize that they happen to be on the stage. Because if you take a look here, maybe you can see my mouse. This device on the floor is actually not facing the audience; it's taking care of lighting of the actor, right? And so these are all stage elements that create the wonderful experiences that we all know. And some of the devices might be kind of hidden, some might be prominent, some of them might look like almost like a backdrop, but again, these are kind of lighting devices. This might be a powerful laser-based fixture. So all of these components, including, for example, control boards, are what is necessary to create all these real-world experiences. But if we go a little bit further from being immersed in this live environment and look at the scenes from a bit of a distance, we might realize that even a large stage like this is actually very small compared to the rig hanging above it, right? And so here in the corner, we can maybe see a camera crew. At the top, we can see various screens and panels and maybe projection surfaces, plenty of trussing, cables, wires. And so we realize that there probably is a large engineering effort behind this, and that everything has to start somewhere from planning. Now, for this planning, we need precise data, and we need precise information, for example, about the lighting devices being used. You can see some over here. maybe about the trusses. What are the load-bearing capacities? What are the junction points? What are the dimensions? And so we need to design our stages. We need to design the electrical parts. We need to make sure that the lighting control operator has proper information about the devices. So they need something like a driver for the fixture which we manufacture. And also when you start looking into even preparing these stages or events, there is plenty of pre-programming visuals being created by visual artists. And so pre-visualizers or with static and dynamic animations come into play in order to prepare the event even before anything happens, all right? And so originally come from a place that is completely lacking some open and comprehensive formats to describe the devices, to create the digital twins. Also, the industry was completely lacking data exchange formats. If you wanted to transfer data from one software to another, one would use some archaic tools, probably based on ASCII formats without UTF-8 support and so on and so forth. And so there was a complete absence of some consistent and functional workflow. So enter GDTF and MVR, the general device type format. Maybe here for the audience, I came up with the general digital twin format because this actually describes it pretty well as well, right? And MVR, so the My Virtual Rig, the scene description format. And so GDTF allows us to describe the devices. And these devices could be anything that is present on the entertainment stage. Lights, lasers, video screens, anything. My Virtual Rig, that is the scene based on the jigsaw pieces of GDTF or further data that are included with the GDTF, like the positions of the files or textures or video streams, arbitrary, 3D GLTF based assets, and so on and so forth. And these two formats are not the end goal. The end goal is a complete workflow where data can freely flow between the CAD applications of the engineers, of the planners, to the visualizing, pre-visualizing crew who might amend the data, send them back to the engineers. It goes to the console operator who starts programming and assigning addresses to these devices. And so the MVR workflow is the ultimate goal of GDTF and MVR. So who are we? Where do we come from? GDTF was started by 3 companies who cooperated on the effort. We partially might compete with each other, but we have a common goal of trying to make sure that our productions go through smoothly, that we actually save money by being able to cross-cooperate and communicate. So MA Lighting is a company which specializes in designing and manufacturing the lighting control boards. Vectorworks is providing Vectorworks planning and visualizing software, and Robe Lighting is a manufacturer of the lighting devices themselves. And our, well, I don't want to say a result because this work is ongoing, right? But the result is a royalty-free open source formats which allow us to describe the devices of the entertainment industry. There is a unified definition for the exchange of data, and this all together creates a workflow of the data between design, planning, controlling. So let me do a quick demo over here. We are in the screen of the Vectorworks software, and the demo will go through pretty quickly, but that is the idea, right? So we are designing our stage. Maybe we are in the 2D, in 3D space, in fact, and what we will do is export this file as an MVR. Then we open it in the lighting console, which has its own specific software. We import the MVR file, and the operator, when they save and exit, have exactly the same view available to them, which gives them the ability to control the devices, grab each of them. They know features of the devices themselves. They can also visualize them. Now I need to move to the next slide from the video. Beautiful. So this will be some of the devices as the sort of digital assets or fixtures. But again, our effort started with lighting fixtures, but we then expanded. You'll see where to. And this will be some of the pre-renders of the artists when they are working on some of their designs, right? So a little bit of history. I think each of the companies started even before 2017, but at that year we met and we decided there is time to do something with the lack of these formats. And we actually announced the GDTF effort at one of the major industry exhibitions in 2018. We released a version 1 of GDTF in 2019, but immediately we realized that this is not enough, that the specification itself needs to have some formal processes, that there needs to be inclusion, that we need to be able to have a review process. And so we started working on standardization. And so in June 2020, we actually released version 1.1 as a DIN spec 15800. So this is not like an international standard, ISO, but it already sets us on a path of thinking in a particular processing way. And this has been very helpful. 2 years later, we have released a DIN spec 15800 2021 as version 1.2 of GDTF. So these are the device descriptions. And then in December of last year, the DIN spec standardization process has released a DIN spec 15801, which standardizes the MVR. And you can see at the time of the standard, it was already at version 1.6 and being used out there in the industry. But this is to ensure that anyone who wants to implement GDTF and MVR don't have to just rely on our word, but there is standing and some grounding to the documents and to the specifications. So GDTF itself, we started with lighting fixtures, static, architectural, or this what we call moving heads, and of course, full description of theirs. And we can go into the details later. Even if we don't discuss everything, these slides will be available to you. And at the, behind the thank you, you will see some technical details that you can observe if you are interested. And so we started describing the lighting fixtures, but nowadays GDTF can describe trusses, stage components, hoists, lasers and their protocols, media servers, projectors, video screens, electrical and data connections. And currently we are working with some audio companies on utilizing GDTF and MVR to streamline their workflow through the show prepping processes. And on the MVR, so on the scene description side, this is basically where the GDTFs kind of get their instances, right? With positioning, with addresses, with UUID, so it can be recognized. Maybe they need to be focused, but also engineers start adding the electrical connections, how everything is wired. We can add arbitrary 3D elements, define sources for the screens, textures, and of course there are plenty of standard engineering practices like symbol reuse, layering, classifications, and so on. And in order to make the workflow even simpler, we have designed, and it's part of the DIN spec, is something called MVR exchange protocol, which is a network protocol to allow discovery and communication of devices on the network. So we would hope that with the work on the spec, our work is done and we can finally do our shows, but that's not it, as you probably know in this group as well, all right? So there's plenty of work on all the other infrastructure. So besides making sure that our specifications are DIN recognized, we also had to create an asset builder or asset creator. We call it the GDTF builder with localizations to several languages. These assets have a sharing platform, which also provides an API for applications to tap into it. And since we are all partners, but at the same time competitors, and we talk about hardware products which are being released on very tight schedule, we all are actually working on the sort of virtual drivers right before the releasing very often, right? And so we have to make sure that none of the companies who are responsible for providing this online share or builder have access to these assets. So German Association for the Lighting Industry, VPLT, is actually hosting these servers to create some spacing or distancing from us, providing the applications, and them being responsible for the servers. There are more. There is a C++ library to read and write these files. And of course, these applications also have some error checking capabilities to make sure there is quality in the data. So the DIN spec already gives us some path towards how we should work with each other. And so we utilize public GitHub repositories for the code, for the text of the specifications, and for proposals. And we also have established working groups, not only for the technical specification, but also for marketing, for training. We hold monthly online technical meetings like this one, where we share feedback, we discuss proposals, we also discuss education, because we want to make sure that the data has good quality as well. And since we host the sharing and creating platform, if people have issues, we have to make sure there is help for them as well through the help desk system. So our social and media teams also help to share information about our project. So the typical things like YouTube, Facebook, press meetings, but we also hold dedicated booths at major exhibitions. So we all who actually take care of these booths are in fact volunteers on the booth in order to share and spread the word around and about GDTF and MVR with the overall goal to unify the industry. And so here is one which happened early this year. Yeah. Training resources, so there are videos and webinars, manuals, and forums. So there's plenty of work on the background besides the work on the specification itself. Ongoing work. So without diving into too much detail, I already mentioned the audio devices. We currently have been working also on some complex pre-programmed sequences in the lighting fixtures, which are quite difficult to visualize. And this would help creative artists to, again, have really good digital clone of the devices themselves. So it's one thing to have some file formats, some even standardized, but where are the implementations? And so there are major lighting and live entertainment players who have adopted these standards. There are more than 50 manufacturers of hardware who provide GDTF files for their devices. And there are probably more than 50 or 60 projects that actually utilize GDTF and MVR in their consoles. Here, Unreal Engine by Epic Games has an implementation, or Carbon for Unreal, again, for kind of visualization of the entertainment devices. Some of the pieces of software, like media servers, might generate the GDTF on the fly because it's not a fixed hardware device, but needs more dynamic configuration. Key, again, players in the lighting industry who implemented GDTF and MVR itself. And one of the people who done a lot of work were the kind folks at the Moment Factory, who created the Omniverse MVR GDTF converter and created the native OpenUSD file format plugin. And this is the time where I hand this over to Arnaud, who will share about his experience of utilizing GDTF and MVR on his site. We can then come to the discussion. Thank you very much. Arnaud, your
great introduction, red carpet. Thank you so much. Actually, that was more red carpet for you because, my contribution to this was just to put yourself in contact with Patrick Cozy, because I've been following the Metaverse Forum for a while, and also talking with you for a while. And I was like, hey, you deserve to present your work, because I think the journey you went through is really interesting for all the people around the table here. So I won't take too long. It's just to present why we came to this and why we came to develop this small plugin. So yeah, we are Moment Factory. We are a creative studio, and we design multimedia experience here in Montreal with audio, lighting, and video. So we are the perfect customer for what Robe and the GDTF and MVR protocol proposes. So we are really excited with this because it sounds like it's going to solve a lot of issues that we have. And it brings an unified way that we can build our show in the future. Last year, I've been working on the OpenUSD first. So I was trying to find my way through OpenUSD and how we could model our experiences as a whole in OpenUSD. Basic Moment Factory experience. It's a venue. It's also scenography. We design specific furniture, specific stages, also AV components and sensors. So I was trying to just build that OpenUSD tree from scratch. But at some point, I talked with the with the lighting people, and they were like, I won't touch OpenUSD because MVR is coming and it's big for us, so we're gonna work in MVR GDTF. That's it. And I was like, that's an issue because probably MVR is not gonna support other stuff. But actually, it came that one of the promise of OpenUSD is to be able to dock other standards to it. So we choose that way. It's not like OpenUSD had to fight with MVR GDTF. So OpenUSD is huge, is about to be widely adopted, supported by major companies. And GDTF MVR is small, but already a standard, really dedicated to what we need. So it was like, how can we make them live together? And that was the purpose of the proof of concept we made. The scope we had was to put more effort on GDTF itself. So we limited the MVR effort to lighting fixtures because that was the main highlight that we needed from this standard. And considering that maybe trusses or other meshes could be held in OpenUSD. And then also we started to unit test the loading of multiple GDTF files. That was part of the scope. We'll have an example at the end. And also we considered that GLTF, do not confuse with GDTF, so GLB files that are part of the GDTF format. So it encapsulates GLTF files. And OpenUSD, the interoperability of these two would become a fact in the future for two reasons. Because of the progress of this very group, of the round tripping and everything. And also recently Adobe released GLTF file format plugin. And that this could unlock something really interesting because also we didn't put any focus on understanding the GLTF and consider it would be something granted in the future potentially, which means the only thing we have to write is something that extracts what's necessary from the GDTF package or the MVR package, and then point towards the GLTF file that's inside, and boom, suddenly with the minimal effort, you just use the general interoperability to do something really interesting. So yeah, so that's basically what we did. The idea of a product is you have the product, you have the AV side. Inside the AV USD file, you have the lighting USD file. So we first modeled this way, for instance, and then we started to say, hey, why not just replace those elements with just payloads? So just point towards an MVR file and point towards a GDTF file. And this is the result of this. So same software as Peter showed. It's from Vectorworks, where we can export GDTF files, sorry. So here we're exporting the full rig. So it's composed on MVR file encapsulating multiple GDTF files. And then we used USD Composer, which is good for OpenUSD. We just I wouldn't say import, but more like link So it's just a payload pointing to the file, and the plugin is taking care of extracting what's meaningful. And also, you will see that maybe quickly at the end of the, oh, there you go. At the bottom, all the information of the lighting fixture. So which means that this workflow is interesting because on one hand, I'm not expecting for all the software we use in our suite will maybe ever or maybe not in the near future like support MVR GDTF. So when we are building this giant tree saying, hey, my project can be represented in a single tree, you cannot leave the lighting blank, or it needs to exist for people that do not live in the MVR GDTF ecosystem. So what is interesting is like you're lacking features, actually. You don't have 100% of the features that are available in MVR GDTF. But at least you have that 50, 60% that allows you to see where the lights are, what are their names, and also all the technical aspect of it, like the power consumption and other stuff like this, which makes the collaboration between the teams really enhanced. We made the Omniverse version of that, but the plugin is actually an OpenUSD plugin, which means we could successfully compile it for Unreal Engine, Blender, and USDView. Potentially more, but that's the 4 we worked out. So from the same plugin, just slide your DLL in the proper folder and access to those features. And all the code is available on our GitHub with other code that we made for USD and Omniverse. But yeah, that's the piece. It's the MVR GDTF converter, like you mentioned. So yeah, then this is the unit testing I mentioned. So we loaded bunches and bunches of GDTF to ensure it was correctly represented in USD. And yeah, I guess that's it for my presentation. But yeah, to open maybe the discussion, it's we feel like we're in between like multiple standards, and I think part of the reason we made that proof of concept is to kind of prove that we can avoid competition between initiatives. And like we feel like OpenUSD has this fantastic capacity to be able to dock other standard and to host maybe an ecosystem of standards. And yeah, that's it for me. Thank you.
Awesome. Thank you, Arnaud. So if anyone has any question, feel free to ask.
Yeah, thank you for the presentation. It's awesome. It's awesome to see that the standards being used in the real world with real lights and real stages. So you mentioned you were assuming that the GLTF and USD are going to be interoperable, which is, I think, a good assumption. Did you have any particular needs in your tool flows, in your workflows? Particular needs for interoperability between GLTF and USD? I mean, in your tooling pipelines, are you finding any friction points where you're trying to use either USD or GLTF and getting them to flow in the round tripping? Are you hitting any problems? Because we're focusing in as a group here on where we should be focusing to try and make sure that we sand down any rough patches for that kind of round tripping. Any issues that you're currently facing that you would like us to focus in on as we work on that interoperability?
Yeah, working on this, I guess the developers struggled a lot with the orientation of things generally, like the axis and whatever. So it turns like from one software to the other, we had multiple. So it's not only linked to GLTF, but it's also linked to OpenUSD. So I guess just the basic orientation. Once that was set, Then sometimes we had issue with the scale, so we had to cheat a bit sometimes to just ensure the scale was proper one. The USD has proper metadata for it, but it's not always interpreted. I don't know about GLB specifically, if you have like any metadata that says, hey, 1 unit is 1 meter. I think so, but I think it's always the same. You're gonna change that.
That's in the spec. 1 unit is always 1 meter in GLTF,
Yeah.
and plus Y is always up. We thought that by setting it that way and not making it configurable, we wouldn't run into this problem where every software like doesn't read the configuration and doesn't understand the configuration. Instead, we ask every software to just, you read a GLTF, you assume it's plus Y, and if your software is plus Z, you flip it always. There's no question.
It's convention over configuration. So this, and I guess materials were doing fine. And then it's more, we wanted to provide a basic light with it, but it's so we didn't go through GLTF this time. It was more like use the native OpenUSD light to just provide a basic something like that, just cast lights. But then it's kind of difficult to align all the parameters of what this light can do and what a light that comes from the VFX industry can do. So it's like those OpenUSD initiatives, like trying to bring back the physical camera, for instance, as a schema. So it's more something that's a big gap between what is physical and OpenUSD that is not yet there in terms of like ability to reflect exactly what this light can do. Did I answer your question?
Yeah, no, that's great. No, thank you.
Thank you.
I have a question for Rob. Robe, actually, I'm sorry, it's Peter, name of the company. I'm very impressed by the speed at which you started your agreement and produced a specification. You had basically a minor version every year for several years. How do you find the participation from their member companies? Obviously, you mentioned there's 3 to begin with. Are you finding that others want to join and make significant contributions, or is it sort of a others join and it's still the primaries that are making the contributions?
I think at this point we are still the primary drive behind the contributions, but we try really hard to encourage companies to talk. And sometimes this doesn't happen publicly. Sometimes they come for private meetings, and so that helps. And sometimes, again, they share a little bit more private feedback on how they envision things to happen. We also know that things do take a long time, because what we are doing is trying to unify a description which each of the companies that already exist in the market has previously solved for themselves, which is exactly the reason why we got to this problematic point of the hardware manufacturers who could just not satisfy the end customer. Because if you make a comparison to your mouse or to your printer, or you say, I make a printer, and with the printer, I should provide a driver, it's kind of easy to say, all right, I'll do a driver for Windows, Mac, or maybe Linux. And if you support CAPS, maybe you even have 2 platforms in one. But if you look at the live entertainment industry, there are some 10, 15, maybe 20, key players, and then there are maybe tens of small ones, right? And so there is no way for us as a hardware manufacturer to support them. So each of the vendors already had their own solution, which means they now have to tweak it to match ours, right? And that is always problematic and always takes a long time. But we are patient. We are here for the long game. We've done this. Robe is 30 years old, right? And so we don't mind to wait, because at the end of the day, what we want to make sure is that the customer has the proper way to actually work with the devices, right? Because if you turn on the TV and there is Eurovision, you know that somebody that night is probably not sleeping well, because they have to make sure everything runs smoothly, right? And those people are us, right? And so what we really try to strive for is to avoid all those flights to those crazy places to support this, designing people and creative people. So if they have the correct tools, they can do this, right? So going back, companies are actually picking up GDTF and MVR, and interestingly enough, it's the hardware companies, the companies who manufacture the hardware, who supported it in the first place, right? And so they are making the move and are telling to their customers, look, here is my device or your device, right? The device you purchased, and here is your driver, your digital twin. You can use it for control, visualization, planning. Now go and talk to your control board vendor to make sure that they support this format, because that will make your life easier, right? And so the adoption has been happening. Sometimes it's behind the scenes. Sometimes we don't even know that companies actually are utilizing GDTF. They sort of scrape the data, but that's fine with us, right? We want to make sure that somehow the data makes it into the digital assets that the customer is using. Even if the customer is not doing it directly, there are visualizers who take the data and create digital fixtures in their software based on our GDTF files. We will be happier if the customer knows, because the idea is that these are open formats. These are, it's typically a zip archive. Inside is a description file, which is human readable. There are GLB files that describe the geometries and so on and so forth. So you don't need much skill to actually tweak the file. And our customers are usually able to say, let me modify this because I need to do something special. And so if they have access to these assets, it's better. But if people just use the data for importing and at least providing customers with the data in whatever form, that also is a good way to kind of start before people switch over to the GDTF format or MVR format on its own.
Thank you. So any other questions? Another question, that is, how big is the entertainment lighting business worldwide?
Oh, you mean, so that's a good question, probably not for me. I'm not the best business person to speak about this, so I have no numbers.
Okay.
I'm sorry.
Ed, and maybe you could help on this. I remember maybe 2 years ago, NVIDIA came and talked about a proposal for lighting, a proposed extension that had lighting specific patterns. You remember that?
Yes, that became, I think, an EXT extension for GLTF. It's the IES lighting standard, which is certainly not in competition with this, but might be useful.
Right. It could be incorporated into that. Are you guys familiar with that standard?
I think Peter is supporting IES.
So I myself am actually not familiar with the standard. We have recently included a proposal into GDTF, which specifically is targeting IES and LDT. So there is European and North American standards, and we support both. There's also something called TM3015 or TM3018, which also includes a similar way of describing the photometric nature of devices. And so basically we've utilized the existing formats, being IES, LDT, and the TM3018 photometrics, to be able to be included in GDTF. So we are not modifying the existing files, but what we defined is particular circumstances when they and how they are being applied. So if there is a lighting fixture which is fixed, everything is easy. It has fixed zoom, and so the shape of the beam is given. But most of our devices have actually dynamic zooming capabilities. and that changes how the photometrics are being represented, right? There are many more factors that can change. For example, you can have what we would call an iris, so basically closing the beam by not zooming, but just scaling it down, right? I think there's a different word in English as well. Anyways, iris, right? And for some long throw fixtures, what might happen is that you zoom them down, but if you are shooting the beam across a stadium, the beam diameter is still too large. So you maybe take the iris and make it smaller, right? And there are two possibilities at that moment. Either the manufacturer of the light has the ability, if it's, for example, LED based, to boost the center of the LED array and provide higher intensity, which means the photometrics suddenly change again based on the circumstances of the light. Or there is the other option that actually the heat and the pressure on the iris is so huge that the iris would physically burn. So the manufacturer, in fact, has to decrease the intensity because they have to protect the light, but they want to provide that smaller, narrower beam, which, you know, at 300 meters is supposed to encapsulate just a person, right? Which means these circumstances, the settings of these particular elements might be or is important to know in order to apply a particular IES file. So I'm not sure if the extension to GLTF would allow us to do something similar, do you know? Or if the way we've done it is, which is that basically we link individual IES files to what we call functions or channel functions, which are particular hardware features of our devices, and we can link to their particular physical values, for example, iris small or iris big, whatever, in just no numbers, then that allows us to link these. Would the GLTF-based extension allow us to do something similar?
So the extension that we have now is pretty simplistic. It just incorporates the IES file and assigns it to a GLTF point light source. So nothing about the IES itself is configurable. You could certainly have the light source move. You know, if it's part of a GLTF file, it's part of a node hierarchy, and the node hierarchy can animate and move over time. You could have a mechanical iris close in front of it, but many renderers don't understand that blocks a point light. We also have an animation, an upgraded animation extension coming out that would allow us to change like the radius of a spotlight over time and animate that. But nothing as sophisticated as what you described earlier. But I would be curious to hear more about if there are weak spots with the integration of GLTF or USD or other 3D formats into into this format, and where the weak points are there and what needs work.
So at this point, we are very happy. The internal models and the kinematic chain is based pretty much on GLB, and we do support textures in there. We try to simplify it. Each model is representing one sort of portion of the fixture, especially if it has movement, because that movement has to be dynamically controlled through another set of attributes that attach to that geometry. Originally, GDTF was started with the 3D assets based on 3ds file format, because that was partially a standard in the lighting industry as well. But we were very happy to move over to GLB, and we kind of try to simplify it. So, for example, we don't define axes by some metadata in the GLTF file, but we say each model is separate, and the composition of the kinematic chain is actually in the description file of the format, right? And what we also do is, for example, we don't utilize the GLTF spotlight, but when designing the digital asset, we can use, well, I'm pretty sure that you can take any arbitrary geometry and make it a spotlight, or maybe not, I'm not sure. But what we do in GDTF is that you can take any 3D file and say, any GLB file, and say that this is a source of light, right? Which later in the application might become an emission surface, right? And might have a spotlight attached, and depending how then the implementation in the particular software is done, right? Which then allows us to model for example, the lenses in a correct way, how they really happen to be on the hardware devices. And so what we've done is we use the 3D assets as sort of generic 3D files. And if we need to define a particular special hardware feature of the light, then we have a special assignment in GDTF for it. For example, for a camera or for a spotlight. We would not use the predefined GLTF camera, but we say this object, this geometry is a camera, and it has given orientation, right? Or this object is a spotlight, or this object is something we call a pigtail, which then defines the connection point for electrical or network connections, right? And so on. This particular geometry is a laser, right? So we kind of, and then we attach a richer metadata to that particular object. It for sure could be done in GLTF by extending it as well. As I say, we kind of started from another viewpoint, and we have the definition lives kind of outside of the 3D world, and the 3D and the definition of that is then merged in the description of the GDTF. I got into it. Hope I described it well.
That's great. Yeah. Thank you. That was a great description.
Are there any other questions or discussions? So we'll wrap this up. We want to thank Petr Vaněk from Robe Lighting and Arnaud from Moment Factory for coming and presenting today. We'll stop the recording, and if people wish, we can hold a water cooler session. For those that don't quite know what that means we leave the session, the Zoom meeting open. It's not recorded, it's not official. But if there's any other questions or conversations that you wanted to hold that didn't quite seem appropriate for the recorded part, now would be a good time.